We will be starting our next talk on Soothsayer at Flipkart, internals of forecasting and modeling. Please join me inviting Ananda and Mohit on stage.
Imagine that you are at Kota, there is an IIT student who is working hard. It's 2 weeks from IT exam, and suddenly he remembers that, oops, I have not yet gone through one of the reference books. Now he's super busy studying. He wants the book, and he doesn't want to go shopping. And this is one of the real promises of Flipkart that, yes, we will deliver it to you at your doorstep. So he goes to the website, and it's out of stock. And it's like, how many of you have had this experience? I hope none, but quite a few of you. Okay. I'm one of the guys to blame for that incident. But any ideas? What happened? Anybody? Bad forecasting? Yeah. And where is the forecasting idea coming from? Okay. So some of the examples, previous trends, what phase of the things, typical supply chain problem, possible any, I heard some other ideas on this side. And why did that have to do anything with, so students never really study throughout the exam, throughout the year? Actually, that's a, yeah. So just to, before I get into the technicalities of what happened, just to clear the problem definition, right? Yes, what you guys said was absolutely right, that the actual demand was higher than what we anticipated. Some of the key phrases I want to take out of this thing is, there's an actual demand, and there is something called anticipation. And this look ahead, or the seller identifying what is required in the market, is a key component that each seller does. Like each kirana wala in India knows this. He has an instinctive understanding of what the market needs. And each bookseller on Avenue Road varies the stock of his books based on what is coming up in the market, what is the demand varying. But so let's kind of go back to our example and see what actually happened, right? Typically, this is what we see. I'm specifically talking about IIT exams, and sorry about the labeling of the axis, but there is a trend of the sales, and suddenly there's a bump. So let's say this is 6 months before the exam. You jump in around 4 weeks or 1 month before, and then there is IIT exam. Now, this bump is what actually caused our out of stock situation. We did not know that this bump happened. So, what can I do? Any ideas again? Sorry? I am not good. Predictive analytics? Yes. But what kind of analytics? What can predict that bump to me? Yes.
This is what normally all the JCPenney and other stuff people are doing.
Pretty much, yes.
Especially around Christmas time.
Any specific examples? Any specific model that you want to call out here?
You want me to give that model name?
You can. I'm game.
They are working on some base or something, but
Okay.
I don't recall right now.
Cool.
Which one?
Anybody else? Or what is the simplest thing I could have done? Time series, seasonality. Any other callouts? You want to?
Okay, this one. Okay, so how can you avoid this? I think so. Sachin and Amod rightly said in the starting that we do have huge amount of data. We have the amount of data of given item, how many people sold, how many people bought it, what time, what location, right? Which people came to our site, browsed which of the, FSN is the, okay, let's not say FSN. Basically, which people came to our site, browsed which all pages, compared which all items, which all people searched for which all keys, right? So we have all those amount of data, right? So let's do one thing. I think a couple of people mentioned the time series analysis, right? So let's take the very first name method, which we call as smoothing, right? Let's apply that solution and let's see how it works, right? So this is the graph which we are carrying from the last slide, right? So this is the IT exam pattern, right? This is the 4 week before bump, right? Now just copy paste the same graph. what we are doing here is a plain smoothing method, right? Now smoothing can be a moving average, a simple weighted, okay. Let me document this. Yeah. So if you just go to that equation, what exactly happening is smoothing is nothing but taking an average out of last k data points, right? And then say my next forecast will be exactly equal to my the average of the last sales, right? So how you start with is the simple smoothing where you don't give any weight to any of the past sales. So what you basically come up with the if a sales is like 5, 10, 5, 10, you just take a plain average and say, okay, this is my next forecast. Now you start putting intelligence to it. You start saying that, okay, hey, why am I giving equal weight to each and every data points? I know that what has happened very recent will be affecting my forecast more, right? So now what you start doing is you start assigning weights to it, right? Now how do you assign weights? So the normal way is like weighted where you keep on decreasing the weights, and one of them is the exponential smoothing. So the equation which you see on the right is basically exponential equation, exponential smoothing method. Why it's exponential? If you just expand this equation, what you will see is that my forecast is dependent on my last sales, and the weight which I'm giving to last is getting exponentially decreasing, right? So what I'm saying is that my forecast is dependent on my last sales, and the weight is decreasing as an exponential rate as and when I'm going back to the history. So one thing which you see is the alpha, right? Alpha in this equation is basically the smoothing factor that decides that how much weight you want to give to your history, right? So if you just take the one extreme, like alpha equal to 1, which means that I'm putting all the weights to my just immediate history. And when alpha becomes 0, it means that you're giving the maximum amount of weight to your extreme last history. So alpha in general lies in between 0 to 1, right? Now the only thing which we have to do here is figure out the right alpha. So let's say we take some alpha equal to 0.4 or 0.5. The forecast which you get is that black line, right? So now what is the problem with this graph?
So any readings from this graph? What is happening? If you look at the black curve and see the forecast, do you see any problem? Is it working? Right. There is a specific pattern to that. Exactly.
Right.
The keyword is lagging. We are always behind our sales.
Right.
So we kind of tried something else.
Sure. Go back.
But we
Yeah.
basically at Flipkart we kind of ran into this problem. We dug into data. We tried to see what is happening. And there is one thing that's every single one of us know about IIT exam. It's that it happens every year. It's periodic. There is a seasonality to IIT exams. So we looked at some data and tried to see is there relevance between 2011, 12 and 13.
So this example from a gate book, right? So if you see the pattern, this 2011, 12, 13, right? So each every year you see the exact same pattern, right? In the September, October there is a bump. Then in the November the numbers goes down. Then December the number again goes up. And if you change this cycle, December and November numbers are actually higher. So what we get is the pattern repeats, right? On a year-on-year basis, the pattern doesn't change. If it is happening in the last week of let's say April or May, the exact time at which IIT exam happened doesn't changes. So the exact curve which it will follow on a year basis is not going to change a lot, right? So now how to use this information? So now we arrived at the initial equation which we saw was basically a single exponential where we only took the base, right? We only considered what is the quantity which I sold in the history, right? Now just extrapolating that equation itself, now we are using a base, a trend and a seasonality. So let me break it up, right? So base is nothing but a steady state sale, right? If you, let's say there's no exams, there's no up and down going, right? The steady state sales which you are getting is basically your base. Your trend is basically the delta between each and every data point. On a week to week or on a day to day basis, is it going up or down, right? So a sale is going continuously up, with each and every data point, we say that the trend is going up. So similarly, the trend is going down, right?
So in simple terms, you can think of seasonality as a span of the pattern repeating itself, and trend is the difference between consecutive values.
So the values which you see, the alpha, beta, gamma, alpha is basically coming from the last only, that how much weight you are giving to the history. Beta is basically how much smoothing you want in the delta between the data points, right? So one is the absolute data points and next one is the delta between them, which basically guides that whether the trend is going up or down. So the third one here is the seasonality. So which is basically the L, C T minus L. L here is the nothing but the seasonality period, right? Let's say I talk about the exam book. So seasonality, there is a year, right? Every year the same seasonality pattern will repeat, right? So now the CT is basically giving me the seasonality, which is if I have a series, if I just add the base trend, and on top of that, if I add that what exactly has been the change compared to the last year, right? So now I have the equation saying that, okay, hey, this is February, this is March coming up, last to last year, and last year there was a bump in March, right? Take that into account and then do a look ahead. I mean, predict intelligently that, okay, in this March also there will be a bump ahead. So using that equation, I mean, these graphs are actually cooked up, but if you use these equations, this black line will be your actual forecast, something like, right? So now we are,
Yeah, so it actually looks like it's working. And we actually saw that it can work. And when we actually tried to use it, I call it cheating, but book publishers did actually cheat.
okay.
Books change every year. This is a practical difficulty we saw in Flipkart, that editions change. Each year people come up with newer editions. So the traditional modeling did not work out for us. The seasonality we had to kind of, there was, one of the things we saw was that we wanted at least 2 years of history, one current, one previous, and new ISBNs keep coming in, especially in the medical section where they sometimes rewrite the whole books. It's not like just updating the example problems, but it's rewriting the entire book, right? So how do we deal with that?
Yeah, so this is just one of the example where, let's say, the Gate book this is a 2012 edition and 13 edition. So what will happen is that whenever a new edition comes up, none of you will go and buy the old edition. Everybody wants the updated edition in the exams like Gate and those things, right? So what will happen? All of a sudden, the sales of the old edition will stop and the new edition will start picking up. So if you combine the history, then you will see a nice curve with a seasonality. But for a data, these two are two different items having a two different sales history, right? So now challenge is that the edition keeps on changing, and what Ananda mentioned, that we need minimum 2 years of history. So you need, so let's say this 2014, you need to know what happened in 2012 and 13, so you can map that, okay, hey, 2012 was followed in 2013, hence there is a seasonality, and now I can apply on 2014. So you need minimum 2 years of data to figure out that there is a seasonality pattern, and that can be applied to this year.
So, but how do I solve it? Any ideas or thoughts around how can we actually link the items? How do I relate to items? Grouping? Yeah. Yes. Yes. Cool. Yeah, exactly. More of the technicality, but at a slightly abstract level, it's the clustering. We need to do clustering at this place to figure out the common groups of books that behave together. And kind of put them together into what is called as
Group seasonality index. So this is the final thing which we did for this specific class of problem, right? When you have items which don't have a rich history, editions keeps on changing. We try to form a group of items which do have a common seasonality pattern. So let's take example. Let's say we combine all the ITJ exams, or ITJ books, right? Or we combine all the, let's say, Gate books. If you see the combined history of them, then you find a very nice seasonality pattern over a period of time, where the history is maintained, history is not discontinuous, and then you can apply that same pattern for this year onward, right? So go back.
yeah.
Oh, sorry. Yeah. So what we do is basically this: we form a group of, let's say, of the items which are going to have a same seasonality pattern. From the previous equation where we are working on the triple exponential, we have a base, trend, and a seasonality, right? So what we are saying is that we are taking the base and the trend from the item level. So let's say there is a Arihant book which is very high selling, and there is some other JE book which is not that high selling, right? So the base will be taken from that specific item, right? Let's say the Arihant is selling something like 100 per week, other is selling just like a 4 or 5 per week. So the base will be taken care of from that FSN, from the item itself. The trend, which is the delta, which is the gap between each and every data point, is again taken from the same item. What we are saying is that the seasonality factor, which was previously specific for a specific item, has now been clubbed. That whole seasonality is coming from a group rather than from a single item, right?
So yeah, we had to club clustering and time series predictions in one shot. So yeah. It's more around clustering based approach. It's not related to hierarchies defined by the market. For example, books and something entirely different can behave in a similar fashion. Books and pens, for example, will always like probably go together. So when you frame the clusters, you don't want to limit yourself only to the market knowledge. You want to see into the data patterns and apply some unsupervised learning there to extract something you may not have foreseen before.
Okay, so it's kind of a logical grouping, that you're trying to do.
But that hierarchical notion goes as an input. I mean, if you go to Flipkart site, there's a book categorization. Like book has been categorized into entrance exam into again to some other categories. So those again goes as an input to figure out that okay, hey, this group is one which will have a common seasonality pattern, right?
Thanks.
So, yeah, I'll come to the engineering actual implementation a little later, but it is, the way we do it is a semi-supervised approach. At scale out, machine takes it automatically, and there is a override facility where monitoring is done and outliers are corrected by humans. But you cannot conceivably do it for 21 million products that we sell. That's the scale problem we run into.
As I understand, the clustering is done based on the seasonality trends of the product. So how do you accommodate the new products for which the seasonality is not known? How do you put them into any cluster to find out what should be the representative seasonality for that item?
Okay, so it's slightly reversed in the sense that we need clustering to identify the seasonality. In the sense, to know that this product will sell like this, you need to know which group it belongs to. So you will have some limited information, maybe it has been selling for 1 month or 2 months, but you will have metadata around, is it an exam book? Who is the author? Who is the publisher?
Right.
That information is ultra important to do the clustering itself.
So then I probably lost something. Like, how do you do the initial clustering? Is it based on the metadata of items, or is it based on their seasonality trends, etc.? How do you even come up with a cluster of or group of items?
It's the metadata plays higher weightage, but if there is sales data, we don't discard it.
So something like hierarchy goes as a strong input to that. So if there's a hierarchy saying that okay, these are ITJ or these are GATE exams, that goes as a strong input. Okay, they will have a common seasonality pattern. There are small nuances like you will have a same book for multiple exams, right? How do you handle those things? So that are the cases where it's actually the semi-supervised, where someone has to manually go and say, okay, fine, prune the outliers and then figure out, okay, this is the right group which should go to the system.
So one is, summarize, one is the curve alignment and other is the metadata input for the category. So both of these are weighted
I missed the question. Can you repeat, please?
Can you please repeat the question?
Give the
One
mic.
is the curve, so there is seasonality curve, right? So you see how the curves align. That is one weighted factor. And the other factor is the metadata. And the metadata is like probably boosted a lot more than the curve itself.
You mean for clustering?
Yeah, for clustering.
In essence, yes. In terms of manually curating the data, the sales data is not manually curated, metadata is manually curated. So largely speaking, the supervision comes in the metadata level where categories actually can tag them. We can put in the features, but for sales, you can't really curate them manually. I don't know if I got the question right. Okay. Yeah.
Right.
What do you do for, how do you convert data into vectors and oh, the question is most of the metadata is not in numerical format. So to do some kind of clustering or mathematical modeling, you need it in the form of vectors. How do you convert this textual and nominal data into vectors, right? No, it's more around feature extraction and feature selection. So when you form your features, there are fairly standard methodologies to do that. Probably we can dump it a little later in the talk, but converting it can be term frequency, etc. But in terms of category, it's less NLP and more we know what it is. So we can actually come up with a dictionary-based approach where there's a category tree in Flipkart. Each of them is assigned a specific value. So IT exams take a specific value. So if an item is tagged as IT exam, it's converted to this specific point in the vector space model. So I can directly do that, and I don't have, so it's a little easier than the natural NLP based approach of term frequency and TF-IDF, but it's still on the similar thought process.
Does promotion also play a part of your forecasting?
Yes.
Is your question more around how does promotion impact forecasting?
Because you haven't talked about in your
Yeah.
forecasting, have you put
I'll come to
promotions?
that.
Right. And the other thing which I was trying to understand is when you cluster your products, does upscale products or cross-selling products also play a factor while clustering?
What is an upscale product?
You upselling products and cross-selling products, does that also factor when you do a clustering, when you define a cluster?
Yes. Here is the thing. The idea is not to cluster only based on metadata. Idea is to identify products which behave together, right? So when you intentionally upsell it, you need to take it as a look ahead signal and say that there is an intent to upsell this. So mark it as an outlier or smoothen the curve, right? So typically the two questions are related, that how does promotion impact and how does upselling impact, right? And in both cases, you need to take the promotion as a factor and smoothen the sales curve a bit to get to the normal day-to-day base pattern, right? So in terms of the modeling, it is more around having a negative weightage to your promotion axis and dampening the effect. There is a dampening factor that triggers in the forecasting model when your promotion are running. Or for the duration of the promotion run, you introduce this factor.
It's the sales and other factors also which you take care when you are doing the seasoning. So when we are taking the exam of IIT, let's assume that it happens in a rainy season, okay? And there's a lot of umbrellas. There can be a peak in the sale of umbrella also. So if all of this, just by going by the sales data, if we pick two items which are like totally disjoint in nature, so how exactly that problem is taken care of?
Okay. So for the purpose of this talk, I have been focusing on sales. But in terms of the actual features that we take into in the implementation, it's actually quite a bit more. So to give an example, views of a product on the web page, right? The page, what we call as page view, is a direct indication of a demand. And so, for example, there are a few Canon lenses in Flipkart that we sell, which every day a lot of people come and view, they want the specs, but they decide to buy it later. For example, they reserve to buy it during Diwali, but they are viewing it day to day. So there is an inclination to buy. They want to buy it. That's a very high indicator of a demand, right? So page views, customer pattern, stuff like price, which is a great demand for, basically if you vary price, your demand goes up or down. So there are causal inputs, and then there is regressive inputs. So sales, I've been playing around with sales in these slides just to kind of bring out the ideas better.
Okay.
But the actual models are much more involved.
Sure. So in this case, as you showed, so we cluster like the products which are probable to go together in terms of sales or prediction. How do you take care of like shift of products? Say Gate. So now for this example only, when Gate next year books come, say 2013, the sales of previous year Gate books is like going to go low. How do you take care of that you don't procure the earlier version that much, and take that to the next version?
So, yeah.
Let me go ahead. So what we are discussing right now is basically just the demand forecasting. What you are asking is basically handled in how we are ordering it. Should we order it or not?
So it's like the demand of the previous year Gate books should be like less, not just based on the trend, because a newer version has come. The demand of the previous year should be reduced.
Right. Let me run through a couple of more slides. When we talk about the system internals, there is a piece actually which says the user interface. So these are the things which none of the system can figure out when exactly the book life cycle has ended, or some of the things which we actually depend on the market intelligence team, right? So they are placeholder where they actually inject this data to the system, and then that's used to improve all those external factors.
But you can use clusters of users and products the way that they behave derive that information, right? So it's not totally.
So it's a yes and no question. For example, Sachin, the question is more around can you derive to an extent can you derive market intelligence through user data, product data and sales data?
Yeah, the graph relationships between
Yeah.
clusters of users and
So
products that behave together.
So there are two extremes.
Yeah.
Sachin Tendulkar's retirement is something none of us could have predicted in any case anyway, right? That's one other extreme. But on a day-to-day basis, something that moves slower, we can predict. For example, mobile phones, right? Typically, Samsung's release cycle. You can approximately say that this year or at the end of early 2015, there will be a new, maybe NS5 kind of a thing. So you can plan ahead for such events. But a dramatic shift in the market is usually something, at least at Flipkart, we have struggled to cope with. And I don't know, ideas are welcome if you guys have faced such problems. Yeah.
One question. Does recommendation and co-purchase also come in picture for forecasting demand?
The problems are related, but not directly.
Basically, I'm saying that let's say for one book we show recommendation of another book. For A book, we show recommendation of B book. So does for demand forecasting of B book, we take in the factor of recommending for A book?
As of today in Flipkart, no, we are not doing that.
But that is something which we would like to have in the system.
It's a good idea actually, but honestly till now I had not thought of that.
I have some question about the bad inventory. Do you handle anything about the bad inventory you have? And there is another question is that do you do this forecasting for all the books, or why should you do for all the books?
Sure. What was the first question?
How do you handle the bad inventory in your case?
Bad means the debt which is not going to sell.
Yeah, so the bad inventory is like bad assets which you have.
There are ways to actually liquidate them, something like put it up for more promotion, liquidate through other channels, maybe give it as a bundle with other item. So there are other not offline, there are other ways to move them out.
And do you do this for all books? Do you require that to be done?
So here is the thing, right? When you talk about groups, you are pulling in more products than you need. For example, your intention may be to sell a Tata McGraw-Hill publication on IITs, but its trend is decided by the whole group of IIT books. So unless you understand the whole group, it's impossible to understand one product. It's like understanding a society to understand a person. To understand one particular book, you need to understand the class of books it behaves in. So your system does need to be scalable, it needs to be scaled out, and it's like there can be 1 or 15 mobiles in Flipkart which are like blockbusters, right? By selling only 15 you can make a lot of profit, but you still sell around, 2 to 3,000 mobiles and you still understand the patterns of all the mobiles, because all of that boils down into how intelligent you can get into individual instances.
Okay, another question is that do you use the metadata from some other providers also, like the mobile usage in particular areas are getting high or something like that to forecast your inventory?
As of now, we are relying on data captured by us. We are not either buying or crowdsourcing data for forecasting.
So data which we are having with us is only like too huge to manage for. So as of now, we are not seeking anything external. Sure. So some maths. Let me just walk straight forward. Just want to highlight the beta part, which is the trend. So trend is basically the LIT minus LIT minus 1. Basically, I is the ith product and T is the time frame. So for any given product, the difference between two data points is actually the base. Is actually the trend, and this is the seasonality. So if you see the base and trend, there is I and T, which is for FSN, which is for product, and the time. For seasonality, there is only time, right? So seasonality is same for all the products which are there in the group. So what this does is that for each group, it actually does the forecast for all the items together, right? We can't pick a single product from the group and say I want to forecast only for this. This whole group needs to be forecasted together. So if you see, there are summations here. So this seasonality is actually dependent on seasonality from all the products, and then this goes as a factor in the level, in the base. So something I think we can run this through.
Did everybody get the idea? The specifics of the equation may not be totally important, but the idea is to elevate the seasonality to the group level and then get it back on the individual product level. So again, we are kind of drifting into the area of ordering. The question is more around if your groups are fairly big, if they are not focused groups, it can be difficult for us to pick which product to order, right?
No, I'm not talking about focus group. Let's say there is a focus on IIT groups. Let's not deviate from that particular thing. But when you are grouping it, there are different IIT books from different publishers which are available. Let's say you have a group of 10 books, just to take an example. Now, you do a forecast for the group.
Right.
So based on the seasonality, you say, okay, this particular group is doing extremely well in this particular month. Now, when based on the forecast, the back order has to be placed from your wherever you are getting suppliers. How do you decide that which item in this particular group has to be ordered into this particular quantity? Or is it like the complete group is bought based on the...
No, so when we are forming the group, we are only taking the seasonality from the past, right? The base and the trend is from the current past only. So let's say there are 10 books. It might be possible that, I mean, taking this example only, it might be possible that 2 or 3 of them are not selling this year, right? So we will only apply the seasonality from the past, but it has to sell this year also to seasonality to get added to it, right? So if you see this equation to get the forecast, it's actually base plus the trend and then into the seasonality. So if it's a book which is this year and not even selling, even though last year it has sold, this year base is 0, there's no trend. Right.
Cool. Yeah.
How much of this equation would be applicable to, say, mobile, where there is a version change? Say iPhone 4, iPhone 5, I repeated it all, or say laptop. So I'm saying, would this same equation be applicable
So,
to mobile or laptop where new version has come,
so
a new processor has come?
actually a great question.
So metadata itself has a lot of complexity with respect to memory and, you know the...
Great question. So let me rephrase the question a bit, right? Question is, at a very high level, does a single model fit all? And how reusable our models are. For example, this is what we call as group seasonality index-based method. But in general, what is the workflow? In general, no. We need to build different techniques and adapt different approaches for each of them. So there's no silver bullet for all the more than like, now I think it's 21 million products on the website. And each day around 600 to 700 products go live, new products. So there is no silver bullet. And we need to continuously recategorize the problem, identify whether it's a intermittent demand. For example, I may sell only 5 products per month, but there can be a pattern. 11000011 and again 11000011, right? Or it can be a simple regression. There can be a seasonality. And then we need to dig into the type of the problem that we are dealing with and go into feature selection, figure out which ones are the weighted features there, come up with the appropriate models. So there is a fairly intensive data science activity here. And you need to keep the analysis engaging and on the ground, right?
Sure. To answer your question exactly, that was just one class of the problem and one class of the solution. So that actually depends on the problem categorization. So the first assumption was that it needs 2 or 3 years of history to see the seasonality and apply it. For something like mobile and computer, the shelf life itself is very small. You won't have the seasonality, this model fails there, right? So then there's another model for that. Exactly. So
you need to kind of keep becoming innovative there. The big question, yeah.
This one? This one? Oh. Sure. So modeling, basically these are the bunch of models which we have a model.
I just put them as examples.
MLR is multilinear regression, which is a causal model. GSI is group seasonality index, which we just saw, where we take the seasonality from a group. IDM is intermittent demand model, where if there is a product which is selling like 0101 kind of a thing, none of these model works. So you need a different model for that, right? So IDM stands for that. Exponential is just the naive thing, which you keep on exponentially weighing the previous histories, and you do the forecast. Anything?
So the big question for all the engineers: how do we do it at scale? What are the requirements? And in an environment like Flipkart, how do we actually keep it alive on a continuous basis? Let me kind of walk you through the process. Do stop me if you have any questions. What ends up happening is this: data sources are completely disparate. There is no single data source from which I can pull all the information I need. I've just marked the website as one box, but website itself runs on around 80 boxes in Flipkart. supply chain runs on more than 100 boxes, and the data is completely distributed. There are log files all over the place, databases are decentralized, and my first task is to actually get all the data together in a data warehouse and actually make sure that I get the data I need. So there has to be a business sanitization. It has to be clean data. It's the data I need, and I get into a scalable storage. With the scale of the data, there is a big challenge of how do I deal with training and testing and experimenting with it. I will come to that as a special topic a little later. But the first challenge I need to solve is getting the data. Once I get the data, obviously I need to come up with modeling, and the modeling exercise itself, as we kind of briefly touched, is a fairly intensive process. It's a data science intense domain, and people need to move very fast. They cannot wait for overnight, like 1 or 2 days for all the Hadoop jobs to complete and come back, right? So there has to be some mechanism of modeling. Then I need to actually build the forecasting engine, which should support the scale that we have. It should obviously make my models configurable. There has to be extreme configuration-driven development. There has to be automatic selection of models. For example, at runtime, it has to decide for this product, this model will be working, right? I cannot configure it for each and every product. And there is a output tracking in the sense I need to keep a look on the accuracy of what I'm forecasting. I need to continuously course correct it. And if there are outliers, if I'm losing plot on any of the products, I need to go back and get the data corrected. Obviously, there is an interface layer, like humans, to do all of this, like tracking, accuracy, measurement, we need override controls, reporting, APIs, user interfaces, charting, visualization, all of those capabilities. Once we do this, we can actually serve our actual customers. For example, people who plan our warehouses, people who plan our promotions, people who plan our revenues, and things like how much revenue should Flipkart make in Q2. And it has to come out of these kind of things, right? And how to do order planning. So from an engineering perspective, I have all these problems to solve. And let me walk you through the first realization we came up to is there is no single alternative. We tried with a couple of things, but there is no single silver bullet at scale, at least something that I was comfortable with. We kind of identified 4 main challenges: data consolidation, modeling, and exposure to APIs, reporting, visualization, right? We kind of cornered down on what I've roughly listed there. We had to build custom applications to consolidate the data. So that story kind of went like this: building a data infrastructure, right? The first challenge was data governance. I need clean data. I need data that's reliable, not the junk developers put in logs, right? So there are all these 4 axes there. Don't give me your debug statements, guys. There are APIs, there are databases, there are flat files. So out of that, I build adapters for all the different types of sources, pull it, and put it into message queue kind of an architecture for asynchronous processing. Flipkart is a multi-data center environment, so I need fast data transfer across different physical cities. And then I have a layer of enrichment and transformation, which allows me to put in the business semantics I need, right? And then kind of put it all into a data warehouse. If I go back to the previous slide, the other challenge we had was modeling over R. The choices were tricky here. Modeling exercise itself, we could have gone the route of writing Java code for everything. But what we really wanted was agility of modeling. We wanted people who are good at modeling to move very fast. So we wanted that at scale. As of now, we are using R programming language for all of our modeling needs. And the way we do it is we abstract it out. We have a test data setup. People can use the test data setup for a training and experimentation and come up with the models. And the actual platform is unaware of what happens inside the R code. And so we integrate R with Hadoop. And the actual processing at scale is agnostic of the details of your modeling exercise itself. Obviously, we have this concept of model instantiation, which, for example, for Harry Potter, let's say use multilinear regression model. and it gives me a specific equation with coefficients, that instantiation is stored. Each and every single forecast is stored with the instantiated equation, and that allows me to go back, rerun the forecasts, and kind of see why did this equation come up on that particular day. And that level of trackability is something that is absolutely required in this kind of an environment. So that's kind of the brief overview of the engineering steps. I'm sorry, I'm kind of running out of time also. But major challenges we had and what we are seeing now. One of the things was the experimentation platform that I discussed. It's still kind of evolving. We don't have a very strong experimentation platform allowing all kinds of users, right? So the next step is obviously how can I build a generic modeling platform, not just forecasting platform. Like most of the use cases in this platform today at Flipkart are around forecasting, but how do I build something else, price elasticity, for example, something that works more on causal inputs, stuff like that. The other thing is the one hot debate I always have with my business guys is the accuracy of the models. I predicted something. I predicted that Harry Potter would sell 1,000 items in the next quarter, but then the price changed, price dropped. So the sales actually went up. Is it a model's fault or how is it? Whose fault is it that our forecast was less than the actual sales? And so similar changes in assumptions. Sachin Tendulkar retired. What could I do with it? Or what could model do with it, right?
So important is to improve the reaction time. I mean, eventually, let's say his death. I mean, he retired, and the sales of his books will peak up. So the only thing is that we will be getting it to know after the sales has happened, right? After 1 or 2 weeks after that. So the whole goal is to improve the reaction time. We get to know the events beforehand. We get to plan for that, and then I mean, the whole data flows to the downstream systems.
So, cool. Questions, comments, thoughts? Yeah.
So most of your infrastructure is based on open source solutions. Are you using any vendor-based solution anywhere in your? No.
As of now, no.
As of now. And in your architecture slide, I saw that you are kind of not I mean, it's more transactional data you're storing in your data warehouse. Are you storing metadata, like you have got a metadata storage somewhere, or is it missing in this diagram?
It's just missing in the diagram.
Yeah. All right. So that was the second question. And third question was, how many nodes are you running in your cluster? Is it, if it's not proprietary information?
As I told you, website runs over 80. Supply chain runs over 100.
No,
My transactional, let me walk you through that data, right?
I think he's asking more about Hadoop cluster.
Oh, I know.
Hadoop cluster.
Okay. Hadoop is
I think,
now.
we have a shared resource.
Anybody in Flipkart who remembers that number?
You can share that.
Around rough idea, thousands, hundreds.
Yeah, the mapper node should be more than that.
Mapper node is more than that.
Yeah.
All right.
I had two questions regarding this one.
So there are two aspects, I think. The question is more around with how does Flipkart growth impact our forecasting ability?
How forecasting will be accurately able to predict because the way business happens or the way we are growing has been like changing continuously over day on day or month on month.
So even though we are growing, the pattern itself is not changing. I mean, just take the example previously, that gate exam books. So if you see, Flipkart is growing, right? Our numbers are growing. So you just see the same pattern going up and up. So in 2011 also the same pattern happened. 12 also same pattern happened. 13 also same pattern is falling. Only thing is that the base is growing. There is some amount of organic growth that happening, right? So as such, the pattern doesn't changes much in a couple of the models. We have yet to see an example where the growth has broken our model.
So when you actually predict the base itself might have shifted
Right, so base is what we are taking from the recent past. For base, we are not going to last year. Base is coming from the, let's say, last week or last week numbers only, right? So all the organic growth and everything has factored into that.
Yeah, I had two questions. One thing is that, like for seasonal events, recurring events, how do you handle temporary shift in the event? So you're taking some example, like every year exam is happening in March. Somehow in one particular year, it got shifted a little bit. Still, we need to prepare for it, and next year it will be back on track. And second question was regarding your data acquisition. Will the Bigfoot initiative, which is recently launched, once adoption happens, that will ease your work of data collection, or will it help?
To answer the first question, yes, we largely rely on human overrides to correct the temporal shifts. So we rely on market intelligence and people coming in and telling us that exams are being postponed by 2 weeks or 3 weeks. And the question around Bigfoot, yes, I'm relying on them.
Okay, and regarding prediction, what is more costly to Flipkart, underestimating or overestimating in general?
Both.
I have a question here. Hello.
We can take it later.
So I think a lot of these questions are around the trend factor, right? So how much is that constant? So Flipkart is growing. Let's say it's 100 crores last year, it's 1,000 crores this year, so it's 10x now. But then there is fundamental constraint to how users generate demand. For example, I'll buy 10 books, one phone, etc., etc. So in a way, it's like a zero-sum game, right? Like at least, so yeah, your users might grow from 10,000 to 100,000. Their spending might increase from 3,000 rupees per user to 5,000 rupees per user, but so that whoever is generating the demand, why isn't that? Is there a reason why that isn't being quantified? Like, is that not important at all? Characterizing how. So yeah, there is that trend factor, but then there are properties to that also, right? Specifically to how it will be split across different verticals and also within the vertical preferences, etc. Did you get the question?
The way I'm understanding your question, it sounds more like splitting the input features into more granular features, isn't it? Like consider number of users as.
So this is from the point of view of the person who's generating the demand. So if
what he's asking that if you are buying something, you have 100 rupees, tomorrow also you will come and buy for 100 rupees only, right? And then today 100 rupees goes to some other thing, tomorrow 100 rupees goes to a bunch of things, then each of them cannibalize each other.
Yeah.
Right?
Yeah.
I think the assumption itself that it's a zero-sum game is wrong. Right?
Is wrong. Yeah, sure. I mean, so 100 rupees it might go to 150 rupees.
Right.
But still it's a zero-sum game within the 150 rupees, right? It's not as though, I mean, so that split has to be characterized, or there is no need for that split at all to be characterized. It might grow to 150 rupees. I'm not saying it's going to be 100 rupees, but.
Let's take it offline. In the sense, I'm not completely getting what your question.
Yeah, I have a question.
So let me answer that question actually. So there is two aspects of what you were asking, right? So one is we look at forecasting, one with a product cut, right? So you can do clusters of products, right? The other aspect to forecasting is cutting your user base, segmenting your user base, right? So you can have users who are interested largely. So this is a population in the age group of 20 to 25 or 18 to 25, and they will be interested in a certain kind of products, right? So what is the affinity of a certain user group to a certain set of products, right? That is one way of clustering. The other way to cluster is to just look at, independent of the user, just look at this is a high selling, this is or a lower selling or an intermittent demand kind of or a seasonal kind of product. What are the kind of life cycles? So you can actually cluster based on life cycles, right? The important angle to this is to be able to use both these kind of clustering mechanisms to be able to get to an information about both your users, right, as well as your products, and try to come to a forecasted demand, right? Right? And then there is a second part of your question, right, where the demand for one product is cannibalized by the demand for another product, right? So that is what is called as what we organize as a homogeneous group. So a homogeneous group of products is something that has a consistent demand. It's like all 16 GB pen drives, right? So all 16 GB pen drives, regardless of brand, would be looked at by a consumer as one product, actually, right? So this is something that, if you drop the price by 50% on any one product, the entire demand will come to that product, right? So there is a causal and there is a cross elasticity or a cannibalization of demand. So this is what is called as product cross elasticity, right? And what we need to do is to be able to put these into our models. We are not there yet, but yes, these are the models that are actually available to be able to see all the things from a user point of view, as well as, user independent, just products clustering. Does that answer your question?
My question was more specific. That it's very visible that that's not being taken into consideration, but it was more around the choice about why it was more from a product point of view rather than this sort of a categorization, right? So, yeah. So, was it a conscious choice or was it just a easy?
Wow, lot of questions. Okay.
Feel free to catch up yours during lunch. We are
Yeah.
here only.
And Ananda and Mohit are all yours.